Welcome to AEL. Today, we are talking about one of the most essential components in every circuit, the resistor. What is it? Why is it so important? How do you read its value? Let's find out. A resistor is a passive electrical component that resists the flow of electric current. Resistors help protect components like LEDs, regulate voltages, and control current in almost every electronic device. In circuit diagrams, a resistor is represented by a zigzag line or a rectangle, depending on the standard. The unit of resistance is ohm, represented by the Greek letter omega. Let's say you're using a 5-volt power supply to light up an LED that only needs 2 volt. Without a resistor, the LED will burn out because the current is too high. Resistors drop the voltage and limit the current to keep everything safe. Resistors are also used to divide voltages, create timing circuits, set gain in amplifiers, pull up or pull down logic pins. To figure out what resistor to use, we apply Ohm's law, voltage equals current times resistance. Rearrange it to find resistance. Resistance equals voltage divided by current. Example, if your LED needs 20 milliamperes of current, and you have a 5-volt power source, and the LED drops 2 volt, R equals 5 volt minus 2 volt, divided by 0.02 amps equals 150 ohms. So, you need a 150 ohm resistor in series with the LED. Now, what if you just have a resistor not connected to any circuit? How can you know the value? Well, resistors are usually marked with color bands to show their value. Resistor color coding is a way of representing the resistance value of a resistor using colored bands. The colors are assigned to specific values, and the bands are arranged in a specific order. This allows engineers and technicians to quickly and easily identify the resistance of a resistor without having to read the printed value. Resistors typically have 3 to 6 bands indicating resistance, tolerance, and, in some cases, temperature coefficient of resistance. In a 4-band resistor color code system, the first 2 bands represent the significant digits of the resistance value. The third band represents the multiplier, and the 4th band represents the tolerance. First band, this band represents the first significant digit of the resistance value. Each color is assigned a specific numerical value from 0 to 9. Second band, this band represents the second significant digit of the resistance value and follows the same color code assignments as the first band. Third band, this band indicates the multiplier or the number of zeros to be added to the significant digits. Each color corresponds to a specific power of 10. Fourth band, this band represents the tolerance, which indicates the maximum allowable deviation from the stated resistance value. It is typically expressed as a percentage. Let us take an example with a 4-band code resistor: yellow, violet, red, gold. The first band is yellow, representing the digit 4. The second band is violet, representing the digit 7. The third band is red, representing the multiplier 100. Combining the first 2 digits, 47, and multiplying by the multiplier, 100, we get a resistance value of 4.7 kilo ohm. The fourth band is gold, representing a tolerance of plus or minus 5%. Therefore, the resistor has a resistance value of 4.7 kilo ohm with a tolerance of plus or minus 5%. If color codes confuse you, you can use a multimeter to measure the exact value. Not all resistors are the same. Here are some types: carbon film resistors, cheap, common, good for general use. Metal film resistors, more precise, used in sensitive circuits. Wire wound resistors, for high-power applications. Variable resistors, used to adjust resistance manually, like volume knobs. To test a resistor, set your multimeter to the resistance mode. Place the probes on each end of the resistor. The display will show its actual value. If it's way off, the resistor might be damaged. This is helpful when color codes are faded or if you're reusing components. That is it on resistors. Now you know what they do, how to calculate their value, and how to use them in your projects. If this helped you out, give us a like, hit that subscribe button, and stick around for more awesome tutorials right here on Alpha Electronic Lab. See you in the next one.